we introduce how to scale when the number of users increase. Let's assume you have an application like the Instagram. What the application does is to allow users to register and also upload and share their images. The initial design is simple. You request for one EC2 on AWS, and you request for a static IP, and register your static IP on the DNS. Later on, the client just input your host name like the Instagram.com and get a static IP and send a request to your EC2 service. But the EC2 private IP are subject to change, so you really need a public static IP. But when the number of users grows, you will find that your storage is not enough, and you want a smarter way so that you can request the data faster. So you want to split the data into two parts, the image itself and also its metadata. The metadata are like the user ID, the image ID, and the path to the images. When a request comes, you do not save your image to the SQL, but save it at an object store. Later on, you point the path to the object store. When a user requests the image again, you go to the SQL, find the matching user ID and the image ID, and then go to the object store to fetch the image. When your user grow again, you need more. Like you need to split your service. Now you add a load balancer to your web service. It's because you have more than one web servers now. The load balancer will direct a user to a certain server. It's much like you go to a restaurant and there is a server that serves you only. When the server serves you, you cannot change the server. Then it's up to the load balancer to decide which server to choose. An easy policy is according to the name. Let's say the users whose the first character of his first name is A, go to the web server A. The users whose first name starts from B go to the second web server. You also want to split the write API and the read API simply for the functional. But for the CDN, the full name is called the Content Distributed Network. It's much like a cache. Now, when a client comes to request for the image, the client first time it goes to the storage to fetch the image from the object store. But you do not want the users always go through the long chain to get it from the object store. Rather, you hope there is a cache so that the client can go to a different place to get the image, and that is called the CDN. There are two mechanisms to replicate your image to the CDN. One example is pull request. Like for the second time, a client asks for the image. The image has already saved to the CDN, so the user does not go to the object store for its image, but go to the CDN for his or her image. When the client grows again, you find you need more web servers and more write API, read APIs, which means you need more CPUs. By this time, you wanted to increase the number of your services. Now you find on the bottom of this photo, we split the read and write SQL. And because we find usually for a service, there are more read requests than the write request. It's easy to understand, right? You upload your image for once, then you share, and 100 of our friends wanted to download the image to view it. So that is why we want to split the read and write. Whenever a read fails, it does not impact the write. With the number of user grows, maybe you will find you need auto scaling. Now, you do not manually scale at the peak, and you do not downgrade because for the sake of saving money. You hope there is a monitor. In AWS, you can use the CloudWatch. So you monitor the CPUs. When the average CPU grows up to 80%, you want to increase the capacity of CPU. So you request for more physical boxes and drop down the CPU usage. And when the traffic drops down, let's say in the evening, you wanna use less machines. And by this time, the CloudWatch detects the lower thread maybe 20%. Now you use the automatic script to request to release some of the services. And at the end, maybe there are even more users and push your system to the extreme. Now you wanna still guarantee the performance. Maybe you can set aside some of the tasks using a queue. Let's say when a user uploads an image, the user finished the upgrading, and in the meantime, you replicate the image to other places. The replication can be queued. It's because the user do not really care if his or her friend can see the image inside or outside of 1 minute. So you can say, okay, we wait until we have the CPU power to do the other jobs. And before we can do, we just save all of the requests in the queue.